When a ray of light propagates from one medium to another, for example, from air to water, its velocity changes, and hence, it deviates from its path. This tendency of light to deviate or bend at the point of separation of two media is called refraction. Let's return to our original question. Why does the pencil bend when immersed in water? What happens to it? Actually, the pencil doesn't really change its form at all. The apparent bending of the pencil occurs due to refraction of light as it passes from air to water. The light bends at the surface of separation of the two media. In fact, any object partly immersed in a different medium will appear bent. Let's examine refraction of light as we saw it in the pencil and look at various terms associated with this phenomenon. The ray of light that is incident on a surface is called the incident ray. The ray that deviates at the point of incidence due to a change in medium is called the refracted ray. The perpendicular line between the two media is called the normal. The angle formed between the refracted ray and the normal at the point of incidence is known as angle of incidence. The angle between the normal and the refracted ray is known as angle of refraction. Let us consider a light ray traveling from air to water. As you can see, the ray of light bends towards the normal. The incident ray and the refracted ray are in the same plane. These observations form the basis of the laws of refraction. The first law of refraction states that when a light ray passes from a rarer medium to a denser medium, it bends towards the normal. When it passes from a denser medium to a rarer medium, it bends away from the normal. As per the second law, the incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane. The ability of light to bend when passing from one medium to another is called refrangibility. Let's compare two situations where we observe the bending of light. When light passes from air to water, when light passes from air to glass, you can see that light bends or deviates differently in both cases. That is, the angle of refraction in both cases is different. The deviation of light depends upon the nature of the two media and the optical density of the two media. The optical density of a medium is determined by a property called refractive index. The ratio of velocity of light in the first medium to that in the second medium is known as the refractive index of the second medium with respect to the first medium. The refractive index remains constant for a given pair of media. Further, the ratio of velocity of light in air or vacuum to that in a medium is called the absolute refractive index, mu, of that medium. If the refractive index of a medium is relatively higher, the velocity of light rays in that medium will be relatively lesser. For example, recall the bending of the pencil in water. As the refractive index of water is more than that of air, light travels at a lesser speed through water as compared to air. Thus, the pencil appears bent. It is difficult to determine the velocity of light in each medium. Therefore, another method of determining refractive index of media was needed. Wilbrord Snellius, a Dutch mathematician, discovered the relationship between the angle of incidence and the angle of refraction for two given optical media. On the basis of this knowledge, he proposed a law to measure the refractive index of a material. This law is known as Snell's law. According to Snell's law, the ratio between the values of the sine of the angle of incidence and the sine of the angle of refraction for two given optical media is a constant quantity. Snell's law can be verified